Hey, all you cool cats and kittens. Today we are finishing up with Unit 2. So we are getting into Learning Outcome 5, or our last learning outcome here. And this is going to be describing muscle actions and force production capabilities. What we're going to look at here is how our muscles produce force, what kind of force they produce, and how we can apply that in a practical sense. So what you're going to get to look at here are a whole bunch of graphs, and we're going to go ahead and break this down from a fundamental standpoint. Now, the first thing we want to look at here is our force velocity curve. What this means is this tells us how much force we can produce from a muscle contraction relative to how fast that force or that velocity of the contraction is. What this is saying here is that the higher the lengthening of our muscle contraction is, the greater the force is that we actually exert. In a practical sense, this means that we start out with an isometric contraction. Whenever you have any muscle contraction, the very first thing that happens is you have an isometric contraction. Think about picking up a weight. So let's say we're doing a bicep curl. You pick up that weight. You don't pick the weight up with your arm or your elbow already flexed where the dumbbell is next to your shoulder. You start out by picking it up and the dumbbell is at your side and your arms are straight out. Whenever you make any sort of muscle contraction, initially it has to be an isometric contraction because your initial contraction is always going to be an equal force to the load you're lifting. Now, why is it that you have low force production at the end of a concentric contraction? Well, if we think about this, when you're at the end of a muscle contraction, or let's say of a concentric contraction, and I bend my hand here, at the end point here, I have nowhere to go. So when my arm is fully bent or fully flexed, there's nowhere for me to go. This means that when I get to the end of my concentric contraction, I have no more velocity to expend, so therefore I can't produce any more force. Where this is tricky is that the end of your concentric contraction is also the start of your eccentric contraction. When you go to an eccentric contraction, you produce the most amount of force. So if you wanted to put on the most amount of strength without putting on muscle mass, you would train primarily in the eccentric force or eccentric contraction type of exercise. Another word for this is negatives. Doing negative exercises or negative resistance training means you are stressing the eccentric movement. When you do this, you have very low hypertrophic capabilities. So you're going to do less for building muscle mass, but you'll do a lot more with building muscle strength because the more force you can produce, the stronger you are. All that strength is the ability to produce force. So as you work an eccentric contraction, You have more muscle fiber recruitment, meaning more of your muscle fibers percentage-wise are activating, and you're going in a direction that is going to really stress those myosin actin cross bridges. So remember, with those myosin actin cross bridges, everything is overlapping. When you do an eccentric contraction, you are pulling those apart. So they want to do their best to hold on to each other and not get pulled apart. Therefore, you're going to have the biggest adaptation to your muscle fibers in terms of strength by doing the eccentric or negative aspect of your resistance work. Now, if you want to really build the most amount of velocity and the most amount of force that you can produce, you need to be training both for maximum strength and for power training. While I don't advocate any single one training method or training philosophy, I will say that the NASM, or the National Academy of Sports Medicine, has a very good understanding and application of developing both force and velocity with their training model, which is shown here. This is called the OPT model, or Optimum Performance Training Model. Where the force velocity curve is most applicable here is in phases 4 and 5, max strength and power. When you are performing max strength means this is like your 1 rep max. So how much can you bench? How much can you squat? When you're at a max strength type training environment, you're trying to move the most amount of weight you can, and you don't care how fast you go. So that's what number A says here. Number A says, I can move weight. My force is super high. My velocity is pretty darn low. Because if you think about it, if I am, for example, squatting 1,000 pounds, do I care how fast I can go? Or do I just care that I can do it? So when you're in max strength, you produce the max amount of force, but the lowest amount of velocity. When you get to power flips the switch here. With power, you do a little bit amount of force, like you do a moderate amount of force, nowhere near what you would do with max strength, but your velocity is extremely high. This graph doesn't really do this service because while this is only a small distance apart, it really is miles apart in terms of the actuality. If you look at power from a physics perspective, power is your work over time. So you would do that as work over changes in time. In a practical sense, what power is this is how much weight can you move as fast as you can control. Power equals function. If I can bench press 1,000 pounds, that's great. But where in my life is that going to actually be applicable? I mean, I guess maybe if I'm, like I say, a football lineman, maybe. But when I have power, I can do functional movement. So power means how much can I move, or how fast can I move as much weight as I can, but in a functional manner. Power then translates into, say, being able to be agile like a running back, or being able to have high velocity with a pitch like a baseball or softball pitcher. You need to have max strength so that you have that force production ability. But if you don't have power, you can't take that force and make it actually applicable or useful to everyday life. Now, here, when we get into this strength curve, this is telling us where or how much force production we have during a given exercise. You have three different types of strength curves. You have a descending, you have a bell curve, and you have an ascending curve. These are all measuring your concentric range of motion, meaning this only measures the strength you have or the force that you produce during a concentric contraction. Now, some of these exercises or some of these are going to have what is known as an ascending curve. An ascending curve means that the force you produce increases as you go through the exercise. Something like a bench press is going to have an ascending curve. If you think about it, with a bench press, you start out lifting that weight on your bench there. And you go down with that weight, and then and again, only the concentric measurement we're going here. So we are starting at the bottom. So the start is here, the end is here. When you start here, you need the most force to get that bar back up to your starting position, or to get that back up to where you lifted it from. That's what an ascending strength curve looks like. Another one that would have this would be, say, a squat. Everyone can start a squat. So if we have our bar up here behind our back, if you go down with that, that's super easy, barely an inconvenience. Everyone can do that, but can you get back up? That is an ascending curve. You need more force to reach the end than you do at the beginning. Now, if I have a descending curve, it's the complete opposite. A descending curve means that I have the most amount of force at the start, the least amount of force at the end. Something that would be a descending curve would be like a hamstring curl. When I do a hamstring curl, here's my hands, here are my feet, here's that little machine thingy, and I'm going to curl my legs over. So when I do this, initially, when I first lift it, I have to produce as much force as I can. It takes the most amount of effort to get me going. And then when I reach the end, it's really easy. When I'm doing something like the hamstring curl, I have to use the most amount of force to get the weight initially up off of its resting place. After you initially get the weight up, it's a lot easier, or gets easier progressively to do that. Now, the last one we have here is a bell curve, or a bell strength curve. What this means is that we have minimal force to start, minimal force to end, but a lot of force in the middle. This is like a biceps curl. When I do a biceps curl, initially you start, and the more you move your arm or the more you flex your elbow, the more force you are generating up to about the middle point. When you're at about a 90-degree curve or flexion with your biceps, so let's say this is your arm, and here's your hand, and this is your elbow here, and that's your shoulder and your wrist. When this is about 90 degrees, that's where you're at nearly your maximum amount. It's actually roughly 80 degrees. You produce your most amount of force there. But anyway, just for brevity here, at about 90 degrees, you produce the most amount of force there. As your arm moves past 90 degrees, it becomes a lot easier. But when you're around that 90 degrees, it becomes the most difficult. Think about any time you've ever failed at doing a biceps curl. You don't fail after you reach that 90-degree mark. You fail before you reach 90 degrees because you're using more and more amount, or you have to use more and more amount of force to overcome that. Once you pass that midway point, it's really easy. But getting to there is the difficult part. So there is your breakdown of strength curves here. A couple more we have. So a length tension relationship. We talked about length and tension in learning outcome 4 here, but there is an optimum length you have, or an optimal length you have, that will give you the most amount of force production. So with tension, remember, is how much force your muscle can enact on an object. Load is how much force an object enacts on your muscle. When you get to your optimal range or optimal length of your muscle, length overall, you produce the most amount of tension. This kind of explains it a little more clearly here in terms of being understretched or overstretched. Think about if you're stretching a hamstring, or someone's stretching a hamstring for you, like you're laying down on the ground and you have your leg kicked up and someone else is here and they are trying to push your leg back. If they don't stretch you or don't push far enough, you don't feel any stretch. You're understretched. If they push you, say, too far, where it's extremely painful, you are overstretched. Either way, if you're understretched or overstretched, you're not benefiting from it. Understretched, you don't get anything out of it. Overstretched can hurt you. But when you reach this optimal midpoint here, that is where you can produce the most amount of tension. So this means that for most muscle movements, you will produce the most amount of tension when you are approaching kind of your midway point of your active tension or your active movement. Optimal length, by definition, just means that you have the most amount or the greatest amount of overlap here between your myosin and your actin. So you have the most amount of cross bridges that are forming. The more of those you have, the more strength or the more tension you're able to produce. Now, the last thing here is this force time curve. This goes kind of in line with the force velocity curve. But what this is saying is how quickly can you produce a lot of force? When you talk about, say, like you may see the term SAQ training, That means speed, agility, and quickness. It's really referring to this. When you have speed, speed is just how fast you can go. And this is irrespective of time. So if I can run, say 25 miles an hour, it doesn't matter if it takes me a second or a minute to get to that top speed, I can still get there. So speed is just how fast you can go at your best. Agility is how fast you can go and then change directions without losing speed. So if somebody is agile, they can be running in a straight line and then change directions and lose a minimal amount of speed. Now, the more practical measurement here is quickness. What quickness measures is how much time it takes you to get to max speed. You may see with like your cars, like this goes 0 to 60 in 3.2 seconds. That is a measure of quickness. Quickness is how much time or how little time really it takes you to get to max speed. So the quicker you are, the more powerful you are. Because again, power is work over changes in time. Work equals force times displacement. Force is your strength. So if I have quickness, I have power. So what this graph says is what happens if I do heavy strength training, if I am untrained, and if I do power training. Unsurprisingly, if I'm doing heavy strength training, I produce the most amount of force. However, to reach my max force, it takes me the longest amount of time. It's not necessarily a bad thing, but it's not as useful as if I have power. If I'm untrained, I produce the least amount of force in the most amount of time, which again is unsurprising. If I'm not trained, then I'm not going to be able to produce much force. I'm not going to be able to do it quickly. However, if I am training for power, so that's explosive movements, think plyometric training, now I can produce a great amount of force in the shortest amount of time. If you notice for here, when I reach 200 milliseconds, I am far and away ahead of everyone. In most all athletic events, the more power you have or the quicker you can generate force, the better off you are. Now, again, if you're going to be like a world class or try to break a world record for, like, say, a bench press or deadlift or a squat, you need max strength. That is going to be your best bet. If you want to be a functional athlete, power is your best way to go. Very rarely are you able to say something is the best at any given thing, but research has shown time and time again that HIIT or high intensity interval training is the best form of training you can do across the board for all types of people, with the exception of ultra endurance athletes. So if you want to run a marathon or greater, or longer, I should say, you don't need to do HIIT training. For everyone else, HIIT training is the best form of training that you can do for yourself. This goes from everyone that is even from say like, a high school athlete all the way up to, an active older adult. So someone that's 65 plus years old. Unilaterally, HIIT training is the best form of training for all cause health and body physiological response. Ironically, the best things never come easy, and HIIT training is actually the least preferred method of training among all people that use it. So even though it gives you the best results, because it's so intense and because it's so difficult, it is the least preferred or least liked or least enjoyable method of training. So keep that one in the back of your head. So that is everything new I have for you here today. For everyone that made it through these 25 minutes, I greatly appreciate it. And for everyone else that wants to just to enjoy the show, I also appreciate any time you've given me here. And until next time, I will see you all later.